Welcome to Control4 Driver Development Essentials. My name is Peter Cosenza. In this video, we'll examine the architecture behind Control4's latest driver file model, the c4z zip file. Additionally, we will see how the c4z structure is leveraged in Control4's latest driver templates by explaining how data moves through a driver created as a c4z using the definition of a Control4 template. In doing so, you will gain an understanding of the areas of a driver template that require your development attention, as well as libraries and common files that can simply be leveraged to assist with the heavy lifting involved in creating a Control4 device driver. Throughout this video, we'll rely heavily on a data flow diagram which provides us with a physical representation of the c4z driver that adheres to a driver template. This diagram and accompanying documentation is also provided as a download here in the Control4 University. Before we begin, it is expected that you be familiar with the architectural and development concepts outlined in the driver development training modules. This includes the 201, 301, 401, and T201 video series. You may find it useful to review the information offered in those training modules before proceeding to develop template-based c4z drivers. It is likely that most of you are already familiar with Control4's previous driver file structure, the c4i file. While very effective, the c4i file is a monolithic file of driver code which uses a basic level of code organization. This presents several issues that make working with c4i files cumbersome, especially larger c4i files. In an effort to improve on some of these issues, and at the same time enhance the way Control4 drivers are developed, the c4z file structure has been delivered, and when used in conjunction with driver templates, makes for a powerful driver development scenario. At its most basic level, a c4z driver is a zip file. It contains numerous folders and files which, when encapsulated inside a c4z zip file, represent a device driver. This modularity within the c4z structure enables a far more organized and structured approach to device driver architecture. It also provides the ability to include many related objects within the confines of the driver in an organized manner. These objects can include items such as graphics and icon directories to support custom user interfaces which can run on Navigator. A c4z file also contains one or more Lua files, which contain all of the driver's Lua code. Control4 driver templates take advantage of the c4z structure by delivering libraries of commonly used Lua functionality. These can now reside in one directory location and can be easily referenced. A c4z file also has its own XML file, which separates the XML portion of a driver from the Lua code. Additionally, rich text documentation can be included in the c4z to support a far superior user assistance model. All Control4 driver development templates are delivered in the format of a c4z file. Now that we've taken a tour of a c4z file, let's look at how the various pieces of a file are used to facilitate communication between devices and the Control4 system. In this video, we'll examine 5 unique data flows that cover the most significant communication scenarios you'll encounter when developing device drivers. These include communication between a device and the Control4 user interfaces, communication from a device which is then used to fire events and set variables, communication from a device to initiate a data request from the device, sending commands from Control4 user interfaces to a device, and handling commands that are unique to a device and not supported through the Control4 device proxy. While this video is generic in nature, we'll use code samples that are applicable to Control4's pool controller template. If after watching this video you would like more information on pool and spa controller driver creation, we suggest watching the template-based pool controller driver development video found here on the Control4 University. Let's take a look at the template workflow diagram to understand how the various areas of the diagram represent not only a c4z driver, but also how data moves through it. Starting at the left, we can see the device for which we wish to write a driver. Immediately to the right of the device, we can see three Lua files: device messages, proxy commands, and device-specific commands. Here are those same files within a c4z file. These files, along with an area correlating with Composer Pro programming, represent the areas within a driver template c4z driver that you, as a driver developer, will be working. We can see a line dividing the diagram into two sections. All of the areas to the right are provided through c4z driver template and are used to facilitate data flow. You, as a driver developer, do not need to modify any of these areas in your development work. Also, in this area, we can see the device proxy as well as representation of a Control4 UI. Now that we have a feel for the layout of the diagram, let's use our first data flow example and see how a c4z driver template handles communication between a device and Control4 user interfaces. We'll start at the left with item number 1. Here we see the device sending a message via its communication port to update the Navigator UI or Composer's Device Control UI. We can see at point number 2 that incoming data from the device must be first parsed by you, the driver developer. This work happens in the device messages Lua file, which is delivered in the template. Let's look at this closer using the pool controller template as an example. All messages sent from a pool controller need to be parsed into a format that the Control4 pool proxy can understand and be handled correctly by your driver. In many cases, the data these messages contain will impact what is displayed on the system user interfaces through proxy notifications. These notifications are predefined for us in the template and can be found in the pool proxy class Lua file. If we open that file, we can see that all of the pool proxy notifications are here. Keep in mind, there is no need for us to edit any of these. Rather, these notifications will be called after we parse the message from the device and create a new function that will pass the data into the pool proxy class Lua file. Our new function will call the appropriate predefined notification, which is sent to the proxy using the Send to Proxy API. All parsing of messages from our pool controller happens inside the device message Lua file. If we open the file, we can see that a simple function has been included. It's called poolTemp, and it is sent from the controller when the pool temperature changes. It is delivered with a value, which is the new pool temperature. Your job as a driver developer is to parse the incoming messages from the controller into a format that can be sent to the Control4 proxy and be displayed as usable data on the user interface. If a device message sends multiple commands within one message, each message must be parsed so that it can, in turn, call a unique function that correlates with this message type. All parsing of device messages is done using the handle message command in the device message Lua file. Continuing to use pool temperature as an example, let's consider a message that comes from the pool controller whenever the pool temperature changes. We want to use the data in that message to update our UIs with the latest pool information. For example, the incoming message might look like this. Without modification, this means nothing to the pool proxy. We need to parse the incoming pool temperature message into a name-value pair, with the name being the command from the device and the value being its parameter. Once the data is correctly parsed into name-value pairs, we need to create a new function for the message so it can be handled by our driver. The value is passed as a parameter to our new function. The proxy class defined in the pool proxy class Lua file provides a template API, or a group of functions that can be called by our newly created function. These APIs are recognizable by the pool proxy and can pass the pool temperature data on to our UIs. The name of these API functions begin with dev underscore. For example, here is the function for handling pool temperature. It's called dev underscore pool temperature, and it takes a temperature value. Knowing this, we need to go back into device message Lua file and build a new function that is based on the pool temp message from the device. It looks like this. In the example above, note that line 1 contains a reference to the Lua table dev underscore MSG. This table holds all of the functions coming from the device. Following the dot, we see the name of the device function, or pool temp. This is the name portion of our name value pair. This is followed by the value portion of our name value pair. It is the variable that will eventually be passed as a parameter up to the UI. Line 2 would contain any conversion that may be needed to change the incoming temperature variable into the correct format for the template, which, by the way, is decimal. It creates a local variable of this value and makes it equal to pool temp. Line 3 calls into the pool proxy class Lua file and its appropriate API called dev underscore pool temperature, along with the new pool temp parameter. This example contains all of the logic needed to create a notification. When the call is made, the temperature API dev underscore pool temperature will take the parsed and possibly converted variable from the pool controller and pass it on to the pool proxy, which will notify the UIs of the current pool temperature, which in our case is 82 degrees. Once we have handled all of the messages that the pool controller sends that require being sent up to the UI in this manner, the Lua development work for our driver is complete. Now let's see how the C4z template handles communication from a device, which can then be used to fire events and set variables. There are instances when a driver may need to handle things that the Control4 proxy simply does not support. For example, a pool driver may want to fire events based on chemical levels in the pool. The concept of chemical management is currently not present in the Control4 pool proxy. However, when a message regarding chemical levels is sent from the pool controller, device messages.lua can also be used to receive the message, fire a system event, and even set a variable to act upon the incoming data. The workflow for this is very similar to that of the previous example, especially with regards to parsing data. However, you will note a change in how step 4 is created. To further explain this, let's continue using pool chemical levels as an example. We need to create a new function in the template device messages Lua file, and we'll call it chemLevel. Within the new function created by the driver developer, the appropriate dev underscore function is called with the proper parameters. For example, in this example, note the line c4 : fire event chemLevel. This line fires an event in Composer Pro. Also note c4 set variable, chem level, value. This line sets a variable which can be accessed in Composer Pro programming. Our next example involves using device communication to initiate a data request from the device. This involves sending data back to the device upon receipt of a message from the device. For example, consider a device that requires a username and password in order for a user to access its data. Once this particular device receives the correct username and password, the device sends a message back acknowledging receipt of the correct username and password. In addition to this, the device's protocol requires that immediately following the delivery of the acknowledging message, a request for configuration data must be made to the device. This type of request can be handled within the device messages Lua file. Once again, the preliminary workflow for this example follows closely to that of the previous examples. Similarly, you will note a change to step 4 and how the function is created within the device messages Lua file. Within the new function created by you, the driver developer, the appropriate dev_function is called with proper parameters. In this example, the message from the device includes a token and status as its acknowledgement. The example sends a request back to the device to get device configuration using the send command. Note the first line in our login function. Its parameter is actually a table containing the parameter value. This table could contain one or many values. Also note the line gcon::send command. This sends the request to the device. Now let's change direction and take a look at communication flow coming from the UI to the device. At step 1, the initiation of a command is sent to the device from user interaction through Navigator or Composer Pro Control4. At step 2, the proxy then calls into the Control4 API received from proxy, which in turn calls into the device proxy commands Lua file using the PRX_CMD command table structure. Device_proxy commands Lua is a c4z template file that receives the command from the proxy and handles it for the driver developer by modifying its format as well as its parameters. Note that the use of device in the diagram will be reflected by the name of the device for which the template has been designed. For example, for a pool controller, the file name would be poolproxycommands.lua. In the example above, you can see that the pool driver template removes the binding ID parameter when it formats the command. This is a unique convention found within this template, as binding IDs are not needed in a pool driver. You should know that this is not typical, and most drivers created for other devices will require binding ID values. At step 4, the device proxy commands Lua file then calls into the generic proxy class Lua file. This is another c4z template file that stores device-specific data within the driver template. It receives the modified command and extracts its t_params table into one or many individual parameter elements for the driver developer. In doing so, it also modifies the format of the command further. For example, PRX_command name t_params calls command name parameter 1. Point number 5. This version of the command is then delivered to the proxy commands Lua file. Here is where the driver developer needs to receive the command and its parameter, modify them in a manner that is valid for the device, and subsequently send the command to the device via the designated communication method. In our final example, we'll see how our C4Z template can handle device-specific commands that fall outside of the proxy definition. There may be some instances where a device has some commands that are unique to that specific device, and the defined Control4 proxy does not have a command to natively accommodate that functionality. This functionality will need to be provided to the end user through Control4 by means of programming or events. In staying with the pool control example mentioned previously, consider that a pool controller has a command to set the chlorination level of the pool spa system. The current Control4 proxy does not have a command to support this. However, the driver developer can create a command to support setting chlorination levels in the device-specific commands Lua file found in the template. These types of commands are not sent to the device through the Receive from Proxy API, but rather the Execute Command API. As stated previously, they are initiated through programming in Control4, such as a button on a keypad or a custom button on a device running Navigator. They can also be tied to events, which can display a pop-up on the UI. Your job as a driver developer will be to define these commands within the device-specific commands Lua file in the template. For example, we can create a command called setChlorinator. It has a state of on or off. Once our driver is loaded into a project, the user will be able to schedule the execution of this command or trigger the firing of this command based off of an event. This concludes the C4Z template instruction video. We hope that this helps you better understand the benefits of using Control4 driver templates to create driver C4Z files in the future.